This is Cbse online classes for NCERT and Cbse 10th standard for all subjects. So, in this session, we will be going with very important 3 and 4 mark questions on quadratic equations. Very important. So, I am damn sure that the problems what I discussed in the previous session of this and the today's session, out of these 2 sessions, one particular problem is going to come in your examination. Sure shot, 100%. Right. So please practice the problems well, and most important thing is this Sunday you are going to write your first midterm examination for 80 marks. So it is highly time bound. So the examination is going to start at 9 o'clock and it goes for 2.5 hours. I am very strict in timings. You have to submit your papers within that particular stipulated time. So please prepare well for the examination. So don't ignore it. More the exams you write, more the confidence you are going to get. More the exams you write, more the silly mistake or the silly errors you are going to do in your examination, you are going to overcome that. So write exams, don't worry about the marks what you are going to score. Just attend the paper, write it for 2.5 hours. Marks is not the criteria. Attending the examination and getting the confidence is the most important thing. So your confidence level at the beginning of examination and after the examination, when you compare your confidence, you will be still more confident after the examination. So write the test, don't skip the test and examination. We don't know what is going to happen in future. Maybe the route what you are going, the path in which you are traveling now is the right path. Learn the things, practice them, be ready. Whenever the government gives you the examination, let us do it. You write it. So until that, keep learning. Right? I wish you all the best for the Sunday's first midterm examination on mathematics. Right? So with this session, we are going with most important 4 mark question today. Very important, very logical, highly logical problems. You have to think. Just getting into the answer is not at all important here. You have to learn the logic. So all these problems today, what I am doing here is time bound problems. So these are the time problems, that is the type of quadratic equation problems which are based on timings. So time based problems, usually in the previous examinations we have seen most of the problems from the chapter quadratic equations, they come from the time related, right? So therefore these problems are very important. So this particular problem what I am going to discuss as the first problem today has been taken from the previous year's Sslc textbooks. Very important, very nice problems, right? Let us learn it. Okay. An aeroplane takes 1 hour less for a journey of 1200 kilometers. So just imagine an aeroplane, it is traveling from point A to point B. The distance between point A and point B is 1200 kilometers. Right. So let us take this as point A. Let us take this as point B. It is traveling from A to B, covering a distance of 1200 kilometers. Very important. Right. Now, here the distance is given, that is 1200 kilometers. So D is equal to 1200 kilometers. I'll write the data. Now, an aeroplane takes 1 hour less for a journey of 1200 kilometers. So we have to understand the physics here. So in the previous sessions regarding some 2 problems I have already discussed this concept. So when we travel from one place to another place at a usual speed, and if we cover the same distance again with a little bit more speed, then what happens regarding the time? So here, when the speed increases, the time decreases. Please remember this concept. This is very important. If speed decreases, then time increases. Remember this once again. If speed increases, then time decreases because they are inversely proportional. If speed decreases, then time increases because again it is inversely proportional. If one decreases, another increases. So here, what has happened here? An aeroplane takes 1 hour less for a journey of 1200 kilometers. So then we may guess that aeroplane is moving at a higher speed than usual speed. So that is the guessing. Usual speed what it was going every day. Apart from that, a particular day it has went with a higher speed. So therefore it has taken 1 hour less to complete the journey from A to B. Right. If its speed is increased from by 60 km per hour from the initial speed. So aeroplane was going at initial speed, at some initial speed every day. But at a particular day what has happened is its speed is increased by 60 km per hour. For example, let us imagine the aeroplane was traveling at a speed of some 400 km per hour every day. But on a particular day what has happened is its speed is increased by 60. That is, original speed is 400 km per hour, increased speed is 60 km per hour. So therefore the speed on that particular day is 460 km per hour. So if the aeroplane travels from A to B covering a distance of 1200 kilometers at 460 km per hour, then naturally the time decreases because speed has increased, therefore the time decreases, right? So now find the initial speed of the plane. What was the initial speed? So we do not know what is the initial speed of the plane, so therefore we are going to guess it. So let the initial speed of the plane be x km per hour. Then distance covered is 1200 kilometers. We have to calculate time. So time is speed by distance, distance by speed. So when you calculate that, you are going to get the hours, in what time the aeroplane is going to take to cover that particular distance, right? We will convert that into the language, right? So let us guess the initial speed. Let the initial speed of plane be x km per hour. So this is our guessing. So what is the distance covered? Distance covered is 1200 kilometers. The distance is covered, right? So we know the physics. We know how to convert this into, so speed is equal to distance by time. So I want time, so speed into time is equal to distance. So time is equal to distance by speed. So this is, we have to do it. So time taken at that speed, that is the time taken by the aeroplane at x km per hour speed covering a distance of 1200 kilometers. So time taken is equal to distance by speed. Distance is 1200 by speed is x. So this value is some hours. It is some hours. We do not know what is that hour because x is the variable here. So time taken is 1200 by x hours. Next, the speed of the aeroplane is increased by 60 km per hour. On a particular day, speed of the aeroplane is increased by 60 km per hour. So original speed of the aeroplane is already x km per hour. Apart from that, additional 60 km per hour. So that becomes x plus 60 km per hour. Right. So speed is increased by 60 km per hour. So that becomes x plus 60 km per hour. So now at this speed, let us take what is the time taken, because distance as it is constant, don't worry about the distance. So here the aeroplane traveling at that is x plus 60 km per hour, that is speed is increased, then we will calculate the time taken by the aeroplane. So therefore time taken is equal to distance by time again. So that is the distance by speed 1200 by x plus 60. So this is some hours. So here the difference between this time and this time is 1 hour. That is, an aeroplane takes 1 hour less for a journey of 1200 kilometers. So this is the time taken when the aeroplane goes at x plus 60 km per hour. This is the time taken by the airplane when it goes at x, that is x km per hour speed. So here the speed is more. Here the speed is more. Therefore the time becomes less. Here the speed is more. Time becomes less. Here the speed is less. So therefore as the speed is less, time becomes more. So now the difference between these two timings is 1 hour. So therefore according to given condition, 1200 by x. This is the larger time value. This is the larger time value. This is the smaller time value. So 1200 by x minus 1200 by x plus 60 is equal to 1 hour. The difference between timing is 1 hour, right? So next is simple calculations. So let us take the LCM for x and x plus 60. So LCM for x and x plus 60 is x into x plus 60. Right, let us take the first fraction, 1200 by x into x plus 60. X and x cancels, so remaining is 1200 into x plus 60. So we have to be very careful with the sign here. So we have minus, so put the minus sign. 1200 by x plus 60 into x plus 60. X plus 60 cancels, so remaining is 1200 into x. That is 1200x is equal to 1. Okay, let us open the brackets here. 1200 into x is 1200x plus 1200 into 60. 7200. 1200 into 60 is okay, 3 zeros, right? So minus 1200x by x into x is x square plus x into 60 is 60x is equal to 1. Okay, plus 1600x minus 1600x cancels, so remaining is 72,000 by x square plus 60 is equal to 1. So we have by 1. So go cross multiplication. So x square plus 60 is equal to, that is 72,000. Okay, so x square plus 60 minus 72,000 is equal to 0. So this is the required quadratic equation. So you have to solve this required quadratic equation by the factorization method. The value of x what you are going to get here will be the initial speed of the aeroplane, right? I hope you got this. So be very careful with the simplification process, right? Okay, let us get into the second problem. Very important, right? You have to understand the concept here, right? So this is from exercise 10.3 and it will be the 9th problem I am going to present. So two water taps together can fill a tank in 9 3/8 hours. Just imagine, be very cool, listen to me very carefully, because it's a challenging problem for a teacher also to convince you the concept. So therefore please listen very carefully. Two water taps together can fill a tank in 9 3/8 hours. Okay, let us imagine a water tank. So there are two pipes coming from sources. So this is one of the water source. From some sources the water is coming inside. So here, this is the water tank, this is the first pipe, this is the second pipe. Okay, when the water comes in both the tank, both the pipes, and from both the pipes, it will fill the tank in 9 3/8 hours. So what is the time taken by both the pipes to fill the tank is 9 3/8 hours. 3/8 is some minutes. Two water taps together can fill a tank in 9 3/8 hours. So next, the tap of larger diameter takes 10 hours less than the smaller one to fill the tank separately. So this is very important. So together they can fill the tank in 9 3/8 hours. Together in the sense, water will be coming from this tap, water will be coming from this tap. Both the taps are going to fill the tank in 9 3/8 hours. Very important. Next condition is, we will close this and we will put on only this one when the tank is empty, right? So water comes from the first tap, which is of larger diameter. It will fill the tank completely. When compared to the timing filled by this particular tap, it will be 10 hours less than this. That is very simple. Let us empty the tank. Let us put on this tap and we will calculate the time taken by the tap, by this tap, to completely fill the tank. We will put off this, we will empty the tank, we will put on the smaller tap here. Let us calculate the time. So the water coming from the smaller tap to completely fill the tank, when we compare both the timings. So here the timing taken by the first tap, that is of larger diameter, when compared to this, will be 10 hours less. For example, it has taken 17 hours to fill the tank, then this tap is going to take only 7 hours. That is 10 hours less than this. But when they are put on together, they take 3/8 hours. When they are individually allowed to fill the tank, the time taken by the larger diameter tap will be 10 hours less than the time taken by the smaller diameter tap. Right? So if this tap takes, for example, I am telling you 27 hours to fill the tank, then this tap is going to take just 17 hours. It's 10 hours less than this. Right? So if this is the condition, find the time in which each tap can completely, that is separately fill the tank. That is the time taken by the larger diameter tap to completely fill the tank. You have to calculate that time, and the time individually taken by the smaller diameter tap to completely fill the tank, that time you have to calculate individually we have to calculate. So very simple. Once again, there are two taps. One is, they are not same in diameter. One is a bigger tap with larger that is a bigger diameter, a larger tap, a smaller one. If the tank is empty and both the taps are put on, they together take the tank to fill in, that is 9/3/8 hours. They fill the tank in 9/3/8 hours. That is together. Now, let us empty the tank. Let us put on the small tap only. Let us put off this small tap only. Let us calculate the time taken by the small tap to completely fill the tank. Let it be some 17 hours. For example, I am telling you 17 hours. Let us empty the tank. We will put off this. We will put on the tap of larger diameter. We will calculate the time taken by the tap of larger diameter to fill the tank. It will be 7 hours. Time taken by this to completely fill the tank is 17 hours. Time taken by this to fill the tank is individually, that is 7 hours. That is the time taken by the larger tap to fill the tank when compared to the smaller tap is 10 hours less. It takes 10 hours less than the time taken by the smaller tap to fill the tank. That is the condition. Right? So now, if they are together put on, they take 9/3/8 hours. So you have to individually calculate the time taken by the larger tap to fill the tank, and also the time taken by the smaller tap individually to fill the tank. Right? So at this particular type of problems, you have to convert the given problem numerical into unit hours. You have to convert into unit hours. For example, this tank fills the tank in 10 hours less than this. Together they can fill in 9/3/8 hours. So you have to convert this into unit hour. That is, let the time taken by the larger tank to fill the tank in 1 hour be. Let the time taken by the smaller tap to fill the tank in 1 hour be. Let the time taken by the, that is both the taps to fill the tank in 1 hour be. So something, you have to convert this into unit hour. Remember this. So similar type, same type of problem, I am going to do it now once again. Another similar type of problem, I am going to do it. You will understand it very clearly. So please follow the words. So here once again, let the time taken by the larger tank, that is the larger tap, be X hours individually. Let the time taken by the smaller tap to fill the tank individually be Y hours. We will guess it. Then we will move on. Right? Okay. Step by step we will move on. Let the time taken by larger tap be X hours. larger tap be x hours. Okay, so let the time taken by smaller tap be y hours. So let it be x hours. So this tap is going to take x hours to fill the tank, and this is going to take y hours to fill the tank. Individually, I am telling you, right? So now, let us convert. For example, x hours means this may be 10 hours, this may be 17 hours, this may be 6 hours, something like that. So now, let us imagine the time taken by the large tank, the time taken by the tap of larger diameter to fill the part of the tank in 1 hour. For example, here, when this tap is put on for 1 hour, this may fill the tank up to here. If we will take out the water, we will put on this small tap of smaller diameter for 1 hour. It is going to fill the tank up to here. Can you imagine? So this is the part of the tank filled by this tap of larger diameter in 1 hour, and this is the part of the tank filled by the tap of smaller diameter in 1 hour. This is 1 hour. So in 1 hour the smaller tap is going to fill this part of the tank, whereas the larger tap is going to fill this part of the tank in 1 hour, because this is larger diameter. Why it is filling more water? Because it is of larger diameter. Why it is filling less? Because it is of lesser diameter, right? So now, together if they are left to fill the tank, then together they are going to fill the tank in this particular part. So this particular part of the tank will be filled in both the pipes in 1 hour. In 1 hour, I am telling you. I hope you are understanding the concept. So here, this is the part of the tank filled by this pipe in 1 hour. This is the part of the tank filled by this pipe in 1 hour. So this is the part of the tank filled by both the pipes in 1 hour. Right? So we will convert that into hour. Unit hour, we will convert that. So part of tank filled by larger tap in 1 hour is equal to, out of x hours it is 1 hour, so that becomes 1 by x. So now part of tank filled by smaller tap in 1 hour, so it is taking y hours, so out of y hours it is 1 hour. So this is the part of the tank filled by the larger tap in 1 hour, this is the part of the tank filled by smaller tap in 1 hour. So that is, this is 1 by x, this part is 1 by x, this part is, I can write it as 1 by y, this part is 1 by y, and now we will calculate for both the taps in 1 hour, right? So therefore, part of tank filled by both taps in 1 hour. So together they are going to fill the tank in 9 by 8 hours. Together both the taps are going to fill the tank in 9 by 8 hours. So that becomes 1 by 9 by 8. 1 by 9 by 8. So it becomes 8 9s are 72 plus 3. 1 by 75 by 8. When you take the reciprocal, it becomes 8 by 75. So this is the part of the tank filled by both the taps in 1 hour. Right? Okay? And then another condition is given. So condition is that the tap of the larger diameter takes 10 hours less than the smaller one to fill the tank separately. So larger tap takes 10 hours less than smaller tap to fill the tank. So that becomes y is equal to, that is x is equal to part of the tank filled by larger tap in 1 hour, that is, let the time taken by the larger tap be x hours. So x is equal to y minus 10. Can we write this? Because the time taken by the larger tap to fill the tank is 10, that is the 10 less than the time taken by the smaller tap. So x is equal to y minus 10. So therefore 1 by x, this one, plus 1 by, instead of x I am going to write that is y minus 10. Instead of x I am going to write y minus 10 plus 1 by y is equal to 8 by 75. So very simple. This is the time taken by the larger tap to fill the tank in 1 hour. This is the time taken by the smaller tap to fill the tank in 1 hour. That when both the taps are put on, then the time taken by both the taps to fill the tank in 1 hour is 8 by 75. So this is part of the tank filled by the larger tap in 1 hour plus part of the tank filled by the smaller tap in 1 hour is equal to the time taken by both the taps to fill the tank in 1 hour, that is 8 by 75. I hope you understood the equation here. Once again, part of the tank filled by the larger tap in 1 hour plus part of the tank filled by the smaller tap in 1 hour is equal to part of the tank filled by both the taps in 1 hour. So that is how the equation is set up. So let us solve this. So 1 by y minus 10 plus 1 by y is equal to 8 by 75. So y minus 10 and y LCM is y into y minus 10. So 1 by y minus 10 into this is y minus 10 cancels. So 1 into y is y plus 1 by y into this, y and y cancels. So y minus 10 is equal to 8 by 75. So y plus y is 2y minus 10 by y into y is y square minus y into minus 10 is 10y is equal to 8 by 75. So let us go with cross multiplication. This into this. So y square minus 10y into 8 is 8 into y square minus 10y is equal to 75 into 2y minus 10. Okay. So 8 into y square is 8y square. 8 into minus 10y is minus 80y is equal to 75 into 2 is 150y minus 75 into 10 is 750. Okay, so 8y square minus 80y, so plus 150y gets transposed, it is minus 150y, minus 750 gets transposed, it is plus 750 is equal to 0. Okay, so once again, next step, 8y square minus 80y minus 150y is minus 230y plus 750 is equal to 0, right? So this is the required quadratic equation. So here one thing you can do is you can take 2 as common here. So if you take 2 as common, you are going to get 4y square minus 115y plus the 325 is equal to 0. So you have to solve it by the factorization method, right? The value of x, what you are going to get here, you have to consider the positive value of y, and that will be the time taken by the smaller tap to fill the tank. And if you want to calculate x, you have to go with this, x is equal to y minus 10, then you are going to get the time taken by the larger tap to fill the tank completely, right? So this is a very important 4 marks question in your examination. Okay, let us get into the third most important problem once again. An express train takes 10th problem in your exercise 10.3. An express train takes 1 hour less than a passenger train to travel 132 kilometers between Mysore and Bangalore. So there are 2 places. one is Mysore to Bangalore, right? Two trains are leaving at a particular time. So an express train takes 1 hour less than the passenger train to travel 132 kilometers between the two places. So this is 132 kilometers between Mysore and Bangalore. So here there are two trains, one is the express train, another is the passenger train. So an express train takes 1 hour less than the passenger train to travel. So naturally the speed of the passenger train will be less when compared to the speed of the express train, because express train is taking 1 hour less than the passenger train to travel a distance of 132 kilometers. So the speed of passenger train is less because it is taking more time, and the speed of the express train is more because it is taking less time when compared to passenger train. Okay. Okay, if the average speed of the express train is 11 km per hour more than the passenger train, so the average speed of the express train is 11 km per hour more than the passenger train. So if this is the thing, find the average speed of both the trains. Average speed of both the trains. So let us guess the speed of the passenger train to be x km per hour. Then the speed of the express train is 11 km per hour more than the passenger train, so therefore it becomes x plus 11 km per hour. So let us calculate the time factors for both the things, keeping the distance constant. You are going to get two equations because the difference in timings is 1 hour. So based on that we will set up the quadratic equation. So the problem goes like this, please follow this. So let the speed of passenger train be x kilometer per hour. So this is the speed. Okay. Distance traveled is 132 kilometers. Sorry, 132 kilometers distance. So now we will calculate the time. So time taken is so time taken t is equal to distance by speed. 132 by speed is x. So this is some hours, right? This is the fourth problem maybe we are doing on this particular concept, right? So now speed of express train is okay 11 km per hour more than passenger train. Okay, so therefore it becomes x plus 11 km per hour. So this is the speed of the express train. So now let us calculate the time taken by the express train to go from Mysore to Bangalore. So therefore time taken is equal to 132 by x plus 11. So this is some hours. So now according to given condition, right, so this time is less because the denominator is more. As the denominator increases, the value of the fraction decreases. So as the speed is more, the time is less. Here as the speed is less, therefore the time is more. That is, the value of this fraction is more. So therefore 132, this is more hours, this is less hour. So 132 by x minus 132 by x plus 11 is equal to, the difference in timings is 1 hour, just like that aeroplane problem, right? So you have to take LCM for this. So x into x plus 11 is the LCM. So 132 by x into this is 132 into x plus 11 minus 132 by x plus 11 into this is, it cancels, so that is 132x. Okay, let us multiply this. So 132 into x is 132x, 132 plus 11. So it is 1320 plus 132. So that is 2541. So 1452. So 132 into x is 132x. 132 into 11 is 1452 minus 132x. Minus 132x by x into x plus 11, that is x into x is x square plus x into 11 is 11x is equal to 1. Okay. So plus 132x minus 132x cancels. So 1452 by x square plus 11x is equal to 1. It is by 1. So x square plus 11x into 1 is x square plus 11x is equal to 1452. So x square plus 11x minus 1452 is equal to 0. So this is the required quadratic equation. You have to solve this. You will get the value of positive value of x. So that will be the average speed of the passenger train. And if you add 11 to that, that becomes the average speed of the express train. I hope you will do this. So I hope you enjoyed all the problems today. Very important problems. 3 problems are done. One is on the aeroplane. Second problem is on pipes. Right, larger diameter pipe, smaller diameter pipe. And third one is express train and passenger train. So all these problems are very important. Among these, one of the problem will be given in your examination for 4 marks or at least 3 marks. So in the next session of mathematics, still more problems are there. Very, very important. You are going to enjoy them. Please watch the video again and again and again to get the concept. This is an advantage in this online classes. You can see the class any number of times you want. I am not privatization. I am not doing any privatization and I am not blocking any videos. It's open. You can see it any number of times. Watch the video. In spite of that, if you get any doubts, please call me or send the doubts through WhatsApp. Right? So keep learning. Stay home. Stay safe. And keep learning. Thank you.